Let me tell you a little bit about myself. I've been with University of Nebraska since '97. My official appointment is 50% research and 50% extension. And extension in United States basically means extending research into practice. So it's basically a bridge between the science and the farms. So I've been part of that system for almost 20 years, and about 95% of my research is actually looking at the applied aspects of weed control in corn, or what you call maize here, in soybean, in alfalfa. Also, we have a bunch of pasture and rangeland in Nebraska, so I've been doing quite a bit of research in those settings. And then also I've been doing a lot of work with the organic agriculture. We actually, I was working closely with a colleague from mechanical engineering, and between the two teams, we actually designed machines that use propane flamers and use the heat to kill the weeds. Obviously, I'm not going to talk about all that. You know, what I'm going to concentrate my presentation today is about the concept of critical period of weed control and some of the yield penalties from weeds being present primarily in soybean. The way I do my presentations, I'm kind of a people person, so I like to walk around and like to look at people's eyes, and don't be afraid of me. I'm not going to bite or anything like that. So I can see whether you can actually relate. They say that the eyes are the road to people's soul, you know, so I can see whether people can relate to some of the things that I'm talking about. So if you see me walking around a little bit, you know, that's just my presentation style. So before I go in, just to give you a little bit about geography. As you can see where Nebraska sits, it's smack in the middle of the United States. We think that we are kind of the center of the country there, that everything revolves around us. You know, it's a small state. It's only about 2.5 million people that live in about, as you can see there, 900 or so kilometers from east to west, and about 400 and some kilometers from north to south. And you have about 2.5 million people that live in that area. So there is a lot of agriculture. That's our main industry. So again, a little bit of a snapshot just to give you a general idea, you know, what kind of agriculture I work with on a daily basis. I'm located in eastern Nebraska. Down here we have Omaha and Lincoln. Those are the two big cities. Between those two cities we have about 1.3 million people. So you can see that another 1 million is just literally spread across the vast land area. The rainfall in eastern part of the state runs about an average 800 millimeter a year. As you head west, it's almost similar to some of the things that I heard about your country. You know, the further west you go, the less rainfall you have. In the middle part, we'll have about 500 mils, and then when you get in the western part, we'll be down to about 300. Here's some statistics. We grow about 4 million hectares of corn. Every year, we grow about 2 million hectares of soybeans, and about 1 million of winter wheat, and about 8 million hectares of pasture and rangeland. In fact, Nebraska has more pasture and rangeland than the cropland. And in that pasture, we raise a lot of beef. We want to believe that Nebraska beef is some of the best beef in the United States, and maybe in the world. And as you can see there, we produce about 2 million hectares of soybeans. So if you guys don't have enough soybeans, don't worry about it. I'll just sell you some from Nebraska, you know. So anyway, and we have plenty of it across the countryside. These are some pictures so you can see what the landscape looks like. It's kind of rolling hills, and all these little tree spots that you see there, that's where the farmsteads is. You know, the Nebraska farmers, they live across the landscape, and that's where his farm is. That's where all of his equipment is sitting in those machine sheds there, and all the land that he farms pretty much sits around the homesteads. The average farm size in Nebraska is about 900 acres, about 1,000 acres. So that would be about 400 hectares or so. That would be the average farm size. And then here in the foreground, you can see some of the alfalfa. In the middle there is the soybean, and back in there is corn. So basically, the two main crops across Nebraska landscape would be soybean and corn. We do have a lot of livestock, a lot of beef production, like I said, in rangeland and pasture settings. But also there are a lot of feedlots. Feedlot is basically a confounded space where they'll put in a lot of cows and feed them, and they pretty much stay in there for the duration of the feeding. They don't really go out to venture into rangeland and pasture. So we have a lot of feedlots. Some of the larger ones will have as many as like a 200 to 300,000 cows on one spot. So obviously these cows need a lot of soybeans, a lot of corn, a lot of feed. So anyway, I guess that's kind of just a quick introduction about some of the agriculture. Most of our crops are herbicide tolerant crops. Our corn right now, it's in about 85% Roundup Ready or Liberty Link corn. And soybeans are about 90%. At one point of time, soybeans used to be almost like a 97, 98%. Over the last several years, because of the Roundup or glyphosate resistance, there are some farmers out there who are saying, well, why are we planting Roundup Ready soybeans? Because I cannot kill the weeds with Roundup. I have to use all these other herbicides. And there are a couple of smaller companies now beginning to sell conventional seeds across the United States. So we have some guys actually going away from Roundup Ready system and going back to conventional systems. So that's why you are seeing a slight drop in Roundup Ready soybean acres. Okay, so this is basically where I'm going to start the presentation that's related to this topic of yield loss because of the competition. I started my job in Nebraska in '97. That was the time when Monsanto started selling Roundup Ready soybeans, and everybody was jumping on the bandwagon of Roundup Ready crops. They started first with Roundup Ready cotton and then Roundup Ready soybeans. And at that time, a lot of farmers, basically just before Roundup Ready was introduced, they were using all kinds of soil-applied herbicides. They'll plant the soybeans, they'll use soil-applied herbicides, pre-emergence, and then the crop will come up, the weeds will come up, and they'll use post-emerge products. When the Roundup Ready system came on board, I would say that probably 80, if not 90% of the farmers basically gave up on pre-emerge herbicides. They can save a lot of money by not applying any soil-applied chemistries. So basically, they would plant soybeans and they will wait for crop to come up. They will wait for weeds to come up, and they will go in and do maybe 2 or 3 shots of Roundup per season, and that was their weed control program. So at that time, you know, basically I'm talking about a situation like this. You know, when you will see the rows of soybeans, the weeds are all in between. This field has never seen any soil-applied herbicides there. So they would look at a scenario like that and they will say, okay, is it time to spray or is it not time to spray? So basically, Since I did my PhD in crop weed competition studies and weed ecology, the two most commonly questions that in that period, and like I said, that's a period of about 10 years, from 2000 to 2010, the two most commonly questions that we were asked is, how do I time that post-emerge application? Again, I'm relating it to this picture. You know, is it time to spray or not? And the second question is that after a couple of years, some of the farmers actually noticed that if they were waiting for these weeds to get too big, they were collecting less yields at the end of the season. So they started asking a question: how much is it going to cost me if I delay my weed control program? So basically, again, I'll be actually showing here 3 pictures, and I'm going to go back and forth between these pictures just to illustrate my points. So this would be a typical scenario from that time where they're wondering should they spray or not. And actually, this is a pretty simple scenario here. Like in this scenario number 2, they're still asking, should we spray or not? You know, sometimes they're trying to save a little bit more money than what they really should save. And I understand, you know, we all live in the world where we got to pay the bills and have families and all that. So we had a lot of fields that looked like that. And then actually we even had fields like this one. As you can see there, these weeds are pretty far ahead, and this farmer was still waiting. I don't know what was he waiting for, but basically he was waiting for something. And so when we look at this scenario here, you can see that these weeds are about 3 to 4 times taller. There is a lot of competition going on. And by the way, this is a no-till field, and this farmer actually planted this soybeans into existing stand of weeds. You know, it would be nice if we can train the weeds to come up like in the whatever time period, and when they come up, we go in, we kill them, and then we go fishing or hunting or on vacation or whatever. It doesn't work like that. So basically, you know, these weeds came up earlier, about 2 weeks before the crop came up, and the farmer just went in and planted soybeans, and he was waiting to figure it out when is the best time to go and kill them. So these are the questions that I've been asked. So as a plant biologist, basically I was looking on the simple competition between the crop and the weed. And the outcome of that competition, obviously, it's going to depend on what is crop, what weed species, what are the environmental factors, you know, what kind of some of the cropping practices are out there, what kind of weed density and species composition. So as you can see, you know, we work in agriculture, we work with the alive systems. The weeds are alive, the crop is alive, and there is competition going on. And the way I try to explain that competition is like race car driving. You have like three race cars on the line. One is a crop, and one is a grassy weed, and the third one is a broadleaf weed. And the guy says, go, start. So the 3 of them are going, and who is going to catch all these resources? The resource is the best. So basically, this is kind of an introduction to this relative time of weed emergence, which means when did the weeds emerge relative to the crop stage, which is actually, you know, I'm leading you into this concept of critical period of weed control. Critical period of weed control has been a concept known for about 40 or so years in weed ecology, and nobody has really brought it into practice. So I was young enough, brave enough, crazy enough, call it however you want, to actually attempt to try to do this. And it actually, it paid pretty big benefits. Now I go all over the world talking about this concept, so I must have done something right there. So basically, the critical period of weed control is the period in the crop growth cycle during which weeds need to be out of the crop, which means the field's got to be weed free. If the weeds come up before a certain growth stage or after a certain growth stage, we call it a beginning and the end of critical period, they usually don't cause much of the yield reduction. So based on some of the research that I've done with my team in Nebraska, we did a lot of work with the effects of nitrogen level in maize and effects of the row spacing on soybeans and how does that impact critical period. So basically what I'm going to do now, I have about 3 or 4 slides just to teach you how the experiments are being conducted to determine the critical period of weed control. So maybe, next summer, one of you can try to do this on your farm. It's pretty easy. If you have a problem, just give me a call or send me an email and we can go back and forth and we can get it done. It's not that hard. So basically, we're the weed scientists. We need to have weeds out there. We like our weeds. Weeds are our job security, so anyway. And, in order to, obviously, determine the critical period of weed control, you need to have two sets of treatments, what we called. One set is when you have a bunch of plots and you keep them weedy, you let the weeds stay together with the crop, which is basically what you see on this graph here. This is your crop yields, and this is your crop leaf stage up to which you allow weeds to stay in your crop. So let's say if you have the weeds come up, your crop comes up, the weeds come up, and they stay in there only for the first couple of weeks or so. You remove them. They probably don't cause much yield reduction or so competition. So your yields will be still up in about a 90 to 100% of the potential yields. If you allow those weeds to stay in the crop for a longer period, obviously your yield is going to go down. And then if you allow them to stay for a duration of the whole season, your yield's going to be really, really low. So this is what we call the Weedy Curve, and this is basically what some of those research plots would look like. These are blocks of different weeds durations, like, somewhere we keep them up to V1, V2, V3, and so on. And then you get the yields, and then you go back and you plot those yields down on this graph. So that would be one set of treatments. And then the second set of treatments, you flip these curves around, and this is what some of the season-long weedy plots would look like in soybeans. So for the second set of treatments, we call them a weed-free curve. It's basically you keep crop weed-free on the beginning of the season, and then you allow weeds to come back, and you let them stay in the crop till end of the season, and then you collect the yields. So, the longer you keep the weeds in the crop, the more yield reduction you're going to have. So basically now what you do is you put these two curves together and you go up in a year, you determine about 95% of the potential yield across these two curves. You come down and you come up with this period from X to Y. That's called a critical period of weed control. So basically that's how the studies are done and the data generated. And when you have a lot of graduate students and a lot of physical labor and everything, and you have a lot of money, all these things you put together, and then you can generate all kinds of data. So using this approach, as part of my master's degree, I actually worked with a colleague up in Canada, in Ontario. As you can see, this was published in 95, so that was published like 20 years ago, and we determined that the critical period of weed control in 76 centimeter rows of soybeans was from V1, which is the first trifoliate stage, all the way up to end of flowering. So basically that means that you can let the weeds stay in there a little bit up to about a first trifoliate stage, and after that you gotta go in and take them out and keep the crop weed free up to about a flowering stage, and then after that some of the weeds that might be coming later on, they may not be as problematic. So this is some of the original work that we were kind of testing the concept. And then when I moved to Nebraska, we actually dove in and we started to do much more detailed work. So we were looking here on critical time for weed removal, which is that beginning of that critical period. We wanted to figure it out. When is the time to go in to remove those weeds? In Nebraska, we grow soybeans in 3 different row spacings. Most of your soybeans here, what I've been told yesterday, is grown in about 76 centimeters. Some of you might be even a little bit wider than that. You have some of these in about 40 or 45 centimeter row spacing, which will be similar to this 38. But in Nebraska, we also have soybeans that are planted in 19 or 20 centimeter row spacing. Those are drilled beans. You're using the same drill that you're using for your wheat, except that you're dropping soybean seeds. The typical seeding rates in Nebraska in any one of those 3 row spacing runs about 400,000 seeds per hectare. And these were all treatments up to what we allow to keep the weeds. V1, 2, 3, and these are all stages and so forth. So anyway, this is what some of the weed-free plots look like. These are the drill beans. These are the 45 centimeter beans. And then this is 76 centimeter rows. And this is the season-long weedy plot, so that gives you a general idea what kind of weed pressure we have in there. Make a long story short, this is what we determine, that the critical time for weed removal in soybeans, depending on the row spacing, ranges from the first trifoliate all the way up to third trifoliate. As you can see, the first trifoliate, or 9 days after emergence, was in 76 centimeter rows. As you start reducing the rows, you are making that crop, I don't want to say a little bit more competitive, but you're making it also a little bit more tolerant to weed presence. So in a 15-inch rows, that was a V2 stage. In drill beans, it's about a V3 stage. In all 3 different row spacings, there was the same amount of weeds. So then you wonder, how come that the critical period is a little bit later in the narrower soybeans? Basically, what's going on there is that the drilled soybeans, the narrow row soybeans, they'll close the canopy sooner, so therefore they're going to start shading the weeds faster, and that's why the critical period is delayed as opposed to 76 wide open rows, which close the canopy much later. So going back to these 3 scenarios now, here is the soybean 76 centimeter rows. You can see there that the weeds are about the same height as the crop, the same height or maybe less. There are a couple of plants here that are a little bit taller. So basically in a scenario like this, you have a primarily competition for moisture. There's no really much competition for light here because of the similar height of the crop and the weed. So in this scenario too, you can see that the crop is much shorter. You can barely actually see the rows in some of the areas in here. The weeds are much taller, so there is a lot of competition here for lights and nutrients. And in this particular field, and these were, by the way, there was a no-till field, weeds emerged 9 days before crop was planted. So, and in this scenario 3, also a no-till field, weeds emerge about 15 days before crop. And they're about 3 to 5 taller than the crop. So obviously there is quite a bit of competition going for both lights and nutrients. So when we plotted, so now in this particular situation, the question is, obviously this farmer didn't spray the weeds in time. So what kind of potential yield reduction he's going to have in this particular situation? So what we did is we plotted all of our yields. Soybean yield losses here against the timing of weed removal. And I have here days after emergence, and I have also a crop growth stage there. So what you can see that in each of these 3 row spacings, this is the 30-inch rows. Obviously, the higher yield losses were in the wider row soybeans than in the narrow row soybeans. So how did we come up with those numbers? First, second, and third trifoliate is basically we use a 5% threshold level. We go across so we can see that in the wide row soybeans, you got to go in and start killing weeds at the V1. In the 15-inch rows and V2, and in drilled soybeans and V3. I talked about this, I shared this presentation with one of the colleagues, and they said, Steve, we can't really grow drill beans here in South Africa because you guys have problems with sclerotinia. And I said, oh, if that is the case, then that's okay. You don't have to look at the data on 7.5-inch rows, but in those areas, I don't know whether you have sclerotinia all over the country, or maybe in some areas you can try to go with the narrower row soybeans. So basically, so now if you, let me illustrate how did we come up with this 2.5% yield loss per every leaf stage of delay. Here I'm saying you gotta go in at the V1. If you don't do that, you go on V2, or by that time you have about 2.5% yield loss. If you wait till V3, you get another 2.5%. So as you can see how these points are connected, and I grew weeds in the crop up to each one of these leaf stages. So this is all the real data. So that's how we came up with a 2.5% yield loss for every leaf stage of delay. And you can see the year when I did this research in 2000. So that's basically 15 years ago, but this data is still very, very valid. So basically, that's a general rule of thumb. I'm not saying that this is written in stone. It's got to be always like this. This 2.5 might be a little bit higher, a little bit lower. Is it a wet year? Is it a dry year? And I'm going to show you more information about that. But it's kind of what we call the general rule of thumb. And this information's been used all over the U.S. and some of the European and South American countries where I was invited to talk about this. And yesterday we were actually looking at some of the economics. So hopefully I did all my conversion rights and everything. But basically what I'm trying to tell you, what kind of economic losses we're dealing with here. If it's a 2.5% yield penalty, so loss of income per every 5 days of delayed control. It takes about 5 days for soybeans to develop one leaf stage, and that's all up to about a V5. And after that, it's about every 3 days you have a new leaf developing. So in terms of economic losses, the current price of soybeans is about $10 per bushel, which is about $370 a ton. And then we use an exchange rate of 12 runs per $1. So that's about 4,400 runs per ton. I hope that my calculations were about right. So if your target yield is 2 tons per hectare, then you're losing about 223 runs per hectare per every 5 days of delayed weed control. And this is how I did all this calculation. If somebody want to check my number, feel free. You know, I used a yield potential 2 tons per hectare. If it's a 2.5%, that's 0.7 bushels, which is about 50 kilograms per hectare. When you go $7.5 per acre for every leaf of delay, times 2.47, which is conversion from acres to hectares, times 12, ends up with the 223. So you lose that every 5 days if your target yield is 2 tons. The higher the yield, the more you're going to lose. If it's 2.6 tons, you lose about 296. If it's 3.3 tons, which is a 50 bushels, which is a typical yield for soybeans in the United States. Anyway, so you can lose as much as 360 runs every 5 days. Every 5 days of delayed weed control. So anyway, so let's go back now to these photos. In this particular field, the weeds in the crop were about the same size. They were about the same size, and the weed control was actually conducted just one day after I took this picture. And then later on, I worked with this farmer, and there was no yield reduction. So this is a situation where you say, yeah, it's time to go in and take the weeds out. Well, let's look at some of those other scenarios. In this scenario too, these weeds emerged 9 days before the crop. So this field actually had 6% yield loss, 6% yield loss. And when I used 2.5% my prediction times 2 leaf stages, my prediction was showing about 5%. So I was basically maybe a 1% off with my predictions. So basically in this particular field, the farmer should have sprayed the weeds before he planted crop, or he could have planted the crop, but before the crop came up, he could have sprayed some burn down treatments in there. In scenario 3, where weeds emerged 2 weeks before the crop, there was 12% yield loss. And if I use my prediction, calculating 4 leaves times 2.5%, basically I would figure it out about 10%. So I underestimated a little bit, but anyway, that's what I'm trying to kind of illustrate here, that this 2.5% yield loss is not a bad general rule of thumb. Okay, so how does that now apply whether you're in a dry year or whether you're in a wet year? The eastern Nebraska typically gets 600 to 800 millimeters per year of rainfall. And when I did these calculations, I was assuming that the crop and weeds emerge in about the same time. So if the weeds emerge before the crop or after the crop, then we're going to adjust some of our timing of weed control. So in our 30-inch row spacing or 76 centimeter wide rows, if you have a wet year, 8 to 1,000 millimeter, the competition for that moisture is going to start a little bit later. So therefore, instead of going in at the V1 stage, the critical period might be at V2. And so also because of enough moisture out there, the 2.5% may not be 2.5%, it might be less. It might be going down to like a 1.5 or 2%. The flip side, if you have a dry year or if you want to apply this in the areas that doesn't have enough rainfall, then the competition for moisture is going to start earlier. It might be at the cotyledon stage instead of a V1 stage. And again, this is all 76 wide rows. And then your 2.5% might be 3%, or it might be as high as 4%. And we've seen that in western Nebraska and some of the drier area with the sandier soil. So I guess that's kind of if you have enough moisture, then the competition for moisture is going to start a little bit later, or if you don't have enough, it's going to start a little bit earlier. And that would be in 76 centimeter rows. And this is what some of those graphs may look like. This is my actual yield reduction in 30-inch rows starting at V1 stage, critical time for weed removal. In the dry years, that might be as high as 3 to 4%. In the wet years, it might be as low as 1 or 2%. Then we did the same thing for 40 centimeter rows, and it's about the same deal. Again, the competition is going to start a little bit earlier or a little bit later, but in terms of percentages, it kind of more or less stays the same. And there's the graph for the 15-inch rows, and then for 7.5-inch soybeans, it would be similar, except that the competition starts later. So basically, this may sound too complicated in Nebraska, at least, or across the United States. Like right now, I think in the state of Nebraska, we have about 800 crop consultants. Those are the guys that work with the farmers. They go out, they scout their fields, and especially if you have a large farm, some of my farmers may be as much as 3 to 4,000 acres. He may have 2,000 acres of soybeans. Obviously, he cannot be in every field checking all this. So he would have crop consultants to go out and scout the fields and try to determine, where is this timing of weed and crop emergence. So this is time consuming, but I guess this is probably the best educated guess that we could come up with. In a no-till system, which is a situation in this field, you can see this was corn, maize planted last year, these are the winter annual weeds that germinate early in the season. The guy's planting his soybeans. This is an 8-row planter. This is one of the smaller farms. and he's planting his soybeans straight into this existing stand of weeds. And then they did that for a couple of years until I started doing this research, and then I go around and talk about all these potential problems. So then after that, what they start doing, they're still using no-till, but they're spraying herbicides before it was planted or after crop was planted, and then before it emerged. And I'm talking about a burn down herbicides, things like, I see you guys have here glyphosate, you have paraquat, you have 2,4-D. So those types of things could be used. Although with 2,4-D, you got to watch in soybeans how you spray and how much you have to have a time before you plant the soybeans, because that 2,4-D, if it coats the seed and the germ of the soybeans, it can hurt the crop. But the idea is, again, to kill those weeds because of that early competition. Okay, so here's the. I try to raise this now to a next level. In terms of, because now we're having issues with the glyphosate-resistant weeds, and the guys are actually now going back and beginning to use more and more soil-applied herbicides. They're beginning to use more and more pre-emergence types herbicides. So they started asking me questions now. Okay, Steve, now if we want to work with your critical period of weed control, and you told us before that in 30-inch row spacing, I have to go in on a V1 stage if I don't use any pre-herbicides. What about if I put down some pre-herbicides? And I said, bingo, that's what I want you to think like that. So anyway, so we did actually, I'm doing the studies right now that are funded by Nebraska Soybean Board. And so this is some of the preliminary data that actually by putting down, you plant your soybeans, you put down your soil-applied herbicide, and basically you're gaining about 2 weeks of that beginning of the critical period. So from the V1, you're pushed all the way up to V4. Basically from 9 days, you're pushed up to 24 days. So that basically means that you plant the soybeans, you apply the soil-applied herbicides, and you don't have to worry for about almost 3 to 4 weeks. 3 to 4 weeks, if some weeds may come through later, then you go in and then you hit them with the Roundup. If it's in narrower soybeans like V3 stage here, you can wait all the way up to V6 stage. So as you can see, you can wait for more than a month before you should worry about a potential second flash of weeds that may come and cause some yield reduction. So that's all about soybeans. And I can pretty much stop here. But then yesterday we were visiting they said there is quite a bit of corn produced here. So I have only 3 slides to show you stuff about maize. So anyway, we also did that work, as you can see, 10 years or so. And we were looking how the critical period of changes in maize is affected by nitrogen level. So you can see here we were using 0N, 55, 110, and 210. This is pounds per acre, which is equivalent of kilograms per hectare. So basically, most of our farmers will be in this range of about 150 or so kilograms per hectare of nitrogen. So as you can see, the beginning of critical period in corn or in maize starts later and later as you add more nitrogen. The end of critical period, it was always about a V10, V11 stage, which is the canopy closure in 76 centimeter wide rows. So, how do you explain this? Basically, the way I explain the fact that, the critical period is delayed by having more nitrogen is like if I had 3 wheat plants and 3 soybean or 3 maize plants at the table, and I give them enough food, they're not going to fight for it. Once I start taking food away, they're going to start fighting or competing for it. So basically, that's a simple way of explaining the fact that the critical period for weed control is delayed by having a little bit more nitrogen out there. And then also we did a similar type of graphing looking at the yield loss, and we came up with about 2% yield loss for every leaf stage of corn, as opposed to 2.5% that was in soybeans. And so, okay, the last 2 slides here is kind of a general take-home message. What I called is that this critical period of weed control is applicable for both no-till and conventional systems. We've done these studies both in the tillage systems and the no-till system, and we were getting about identical results. Reducing row spacings makes soybean a little bit more competitive. I don't know whether that would work for you guys here in South Africa. I like to see guys who are brave enough. You don't have to try your whole farm, but maybe you can try 20, 30 hectares on one side with the narrower soybeans and see is there anything there that may trigger your interest or so. That's the type of farmers that I like to work back in Nebraska, because a lot of these things, you know, we do research at the university in small plots, but I like to replicate that on a larger area with my producers anyway. The average is about 2.5% yield loss in soybeans. If you use pre-herbicides, you're gaining about 2 weeks of that beginning critical weed control. And the economic loss, like I said, these are some of the numbers that I came up just working on those late last night. We went to a restaurant to eat, then I came back to my room and I was trying to do all these conversions. So I hope that my numbers are within the ballpark anyway. How do you actually use this in a practical situation, in the real world situation? It's basically, if I tell you go in at the V1 stage, if you don't use any soil applied herbicides, and you wait for the crop and the weeds to come up, if they came up on about the same time, you go in at the V1 stage and you apply your Roundup together with another herbicide that will have soil residual activity. And most of the soil residual herbicides will give you about 3 to 4 or 5 weeks of weed control, depending which one you use. So that's been a recipe in Nebraska where some of my farmers were using Roundup, and they mix them with different herbicides. I'm just putting some products that are in the United States. I think you guys have Pursuit here, Imazetapir, and I don't know if you have Flexstar or Reflex or Raptor. It doesn't really matter. The concept here is what I'm trying to make a point across. And I guess with that, I think I actually did mine right on time, huh? Despite the fact that you took 10 minutes of my talk, but so that's so I don't know. Do we want to have questions? I still have 10 minutes. I'm amazed that actually I went through this relatively fast. So anyway, so we do have 10 minutes. Do we want to have questions now, or it's up to you guys? Doesn't matter to me. So. Right. Any burning questions?
Are there floating mics? Nobody now?
Come on, don't be shy, guys. You know. Somebody told me that South African farmers are extremely shy. They said we got to give them about 2 or 3 beer before they start talking. So I would say let's bring some beer out. I don't mind drinking beer myself. I'm done with my talk. Now I can just have fun, you know. So anyway, yes, sir.
How do you compare the stunting effect of glyphosate on the plant versus your growth stage of your weed?
Okay, the question was, how do I compare a stunting effect of glyphosate on my crop or on my weed?
On the crop.
In
terms of the yield.
In the varieties, the soybean varieties that we've been using in the United States, we don't have much of the stunting effects on the Roundup Ready varieties that are extremely tolerant to Roundup. When they started developing some of those lines, we were using as high as 20x levels of Roundup, 20x rates of Roundup, and we didn't have any stunting effects. So I don't know what kind of, do you guys have obviously effects like that here in the country? There's the topic for research, you know. This is Mr. Chairman. He's got all the money in the world, so we can put some plots here and figure that out. Sorry, I'm not answering your questions, but I'm telling you exactly, I'm not aware of the stunning effects.
Steve, I'm going to rule that we leave these discussions as we've got them on the program After tea, we've got 2 more speakers, and then the general discussion, and then you'll probably find a bit more lively participation.
Right.
So I wish to thank you very much for your presentation, and we will certainly be discussing quite a lot of it later in the day. Thank you very much.
Sure.